Hello, everybody. I hope you're doing well. So this is the video that would help you review the triple integral chapter. All right. So in this chapter, we have been studying double and triple integrals. And before the test that's coming up, and even before the practice test that you can do, this is another quick review for integrals and how you set up integrals, how you interpret those double and triple integrals. And I cover, several different important topics in this video. And basically, if we were meeting in the classroom in the face-to-face, type of instruction, right before or right after we finish that chapter, I have this one special or one extra day for review. And this is what I would be doing. Okay, so I hope you will learn a lot as you review these problems. And basically, I'll be sharing the answer key, and I'll be going over and just talk about what's important and what to pay attention and so forth. All right, so let's get started. Okay, so before we start on the answer key, let's just make sure we know what we are talking about, right? So we are finished with chapter 5. We have this triple integral review, and this is what I'm talking about in this video, okay? Now, in another video, I will be covering practice number 4. The solution key is already here, but this is not what this video is about. And of course, once you are finished with today's review, and sometime on your own time, you can do your practice test number 4. You turn your homework in, and then you take your test number 4 on chapter 5. And then, of course, you will be showing your work in this or under this assignment. Okay, so the this current video is on this topic, the triple integral review. So you can print this out, and you should try all your problems here. I mean, all those problems, not all your trouble, but all your no, not yours, all the problems you see here, okay? And then I will be showing you or sharing you with you this integral review key. And so this is what I'll be discussing, okay? So you can either have this open or have the other, the integral review sheet, blank sheet open, or maybe, just get your workout from this review. My assumption is that you have tried these problems, okay, first, and then I'll be commenting on these problems as I share with you this answer key. All right, so that's what I will be doing. Let me open the answer key in another program. All right, so this is the triple integral review. Number 1, the integral, and you can see this integral here. I'm going to use a, let's use a green ink for this, my comments here today, okay? So the integral, and you can see this integral here, represents the volume of a solid, okay? Now sketch the solid. Now, of course, you see it right in front of you, so you can see, yeah, it makes sense, right? But your objective is to be able to, based on these numbers, create a little sketch. All right, and you don't have to be good at drawing, but I think by this time, hopefully, you have learned how to, start with X, Y, and Z axis like this, and you're looking at the space, the origin from the standpoint or the viewpoint of a quadrant or the octant 1, right, where X, Y, and Z are all positive. And I will have questions in such a way that you don't have to really make this into a complicated drawing, okay? And what you do, of course, is to look at these numbers this direction. First, you say X goes from 0 to 3. And by the way, some people actually go the other direction. I don't recommend it. I highly recommend that you go from the outside and then work your way in. X goes from 0 to 3, okay, and I normally just write these things down. Y goes from 0 to 5, okay, and then I think, okay, this is great because, X and Y, we know what to do. I mean, X and Y are the most familiar, variables for us, okay, and so at this point, I may even draw a picture like this, because this has to involve the rectangular region on the XY plane because all of these are constant. Okay, and then z, when you get to the bounds for z, it goes from 0 to 3 minus x. So at this point right away, now this is also nice because 0 is less than or equal to z, which tells me that everything is taking place above the xy plane, which I call floor. You know, this is my floor, you know, xy plane. All right, and then because the upper bound involves a variable, and this is the only variable you see in the bounds, you know, you try to sketch z is equal to 3 minus x. Now, what is z is equal to 3 minus x? Or, of course, this is the same as x plus z is equal to 3. You should recognize this immediately as a plane, right? And it's a plane that goes along or goes parallel to the y-axis. Why? Because y is missing, right? And so it's a plane. And by the way, when something plus something is equal to a constant, you basically think of this number as the intercept. Okay, so the x-intercept, well, I mean, the way it works is when x is equal to 0, z must be 3. And when z is 0, x must be 3. Right? And then you connect these 2 points, and then you extend this plane in the y direction. Right? That is the upper bound for z. So now I think you have a pretty good idea of what to do here. X goes from 0 to 3, y goes from 0 to 5, right? So you will be drawing a picture like this here. And then on top of it, you draw this other, the picture of the plane, which is this, okay? And then you realize that y stops at 5, that's this, and x stops at 3, which is this. And then z, of course, you know, stops at 3 or right, so the point is, what this is saying in this order is that first you pick x. Okay, so you pick x at certain point, right? And then, of course, you know, what you're doing is you're slicing this with this x value. And then you ask what y, what the range of y is. Well, y goes from 0 to 5, and this picture shows you that at uh, each x, and regardless of what x is, y goes from 0 to 5. And then for each x and y you pick, okay, this time z goes from 0 to until you hit this point. Now, what is this point? Well, it is this point over the above xy. Where it stops is on the plane, and the plane is described with this equation where z is, of course, 3 minus x. So this is correct, and we are fine. This is the right picture for it. Okay, part B, evaluate the integral and verify the answer using geometry. So this should be an easy part. And my experience tells me that students are much better at evaluating integrals than actually drawing and sketching things. Okay, so again, there is no integrand, and so this must be the volume of this triangular cylinder, otherwise known as a prism. And so first you bring 3 minus x down here, 0, of course, does not appear. And then you just integrate this with respect to y, which just means you just multiply by 5. And now you integrate this with respect to x, but maybe you want to solve this first. That's 15 minus 5x. And if you integrate it over the interval from 0 to 3, you get 45 over 2. No problem, right? And then verify this using geometry. What does it mean? Well, you know that this is a half of a 3 by 3 by 5 rectangular box. Okay, so that's the way you think about this. If you had two of these solids, you can put them together, just like this picture, right? And this would be a rectangular box 3 by 3 by 5. And of course, the volume of this rectangular box would be the product of these numbers, which is 45. And so half of that, which is the prism volume, must be 45 over 2. Right. Now, and then set up the triple integral in the order dy dx dz. Now, that's going to change things a little bit, okay? And the way you think about this is, again, start with the the very last variable written there, which is dz, right? So z goes from what to what? Okay, this time, remember, because z is associated with the outermost integral, you can't have a variable. like you cannot use this 3 minus x outside. So the question is, in this entire picture, z goes from what to what, okay? In the biggest part of this solid. Well, z, of course, goes from 0 to 3. So that's what you will have to write. This, I think, is difficult for some students, maybe many students. All right, so remember that the outside bounds have to be constant, okay? And so 0 to 3 is what z is. And then for each z, you ask what x goes from and to. And so it may help you to have a little slice of z, a slice of this solid when you cut it or when you slice it. When you chop it at a certain z value, right? And that's what you're seeing in blue here, right? And so now you ask the question, x goes from what to what? And the answer is from this point, not all the way to 3, but up until this point when you hit this surface or the plane, right? Now remember, this plane is x plus z is equal to 3. But the question is now, x goes from 0, of course, here, right, to what? And so you have to solve this for x. And this is what you get, of course. So 3 minus z is the upper bound for the middle integral. And then you ask the question, for each z and x I pick, y goes from what to what? And the answer is y goes from 0 all the way to 3, regardless of what x is. Oh, sorry, 5, regardless of x is. So that's why you have y going from 0 to 5. And this y value, the y bounds are independent of x and z. And that just means that whatever x and z you pick here, y goes from 0 to 5, 0 to 5, 0 to 5. Okay, so that's why these are both constants. All right, so that was number 1. I hope it makes sense. Number 2, sketch the solid. Ooh, you may not like this again, right? But that's okay. With practice, you will be good at sketching, at least decent at sketching, maybe really good at sketching, okay? All right, so, people practice art in the same way, drawing. Sketching the solid whose volume is the following, okay? So what I call Jeopardy-like or Jeopardy-type question. Here's the answer. What is the question? Okay, well, so think about this. The integral goes, okay, so the x goes from -3 to +3. So that's what I write first. Okay, and then y goes from 0 to 2. I write those things first. And at this point, I would just go ahead and sketch what is like the domain, on the xy plane. Fortunately, all of these are constants, and that means that you have a rectangular region on the xy floor, otherwise known as the xy plane, over which this solid is defined. Right? And then finally, z goes from 0 to, and that's nice because that means everything takes place above the floor. And then z is equal to this thing here, square root of 9 minus y squared. Okay, so immediately you think of this equation, and then you try to draw that on the yz plane, okay? And then you can extend it in the x direction because x is missing from this equation. Square both sides and move y squared to the other side, and you have this. What is that? Well, that looks very much like a circle, right? Now remember, this is the positive square root, which means this side will not be negative. So z is non-negative, almost always positive. And that means everything is, above the xy plane. So even though this is a circle of radius 3 on the yz plane, as you see here, you don't have to draw the bottom part because z is positive or 0. All right, so that's what you have. And then you can try to draw this, if you try to draw this, the yz plane, which is the yz plane, that's the yz plane. And then you can draw this radius 3 half or semi-sphere, semi-circle, right? And that's what you will have. And then, of course, it sort of extends in the x direction, just because this is, the x is missing from this. But remember, the domain on the xy plane, I shouldn't be calling this the domain because it's not a function, but I should be drawing this only above this rectangular region, right? So x goes from -3 to +3, right? And then y only goes from 0 to 2. Oh, that's interesting, right? Because here I assume that this is the entire semicircle, but it's not. Y only goes from 0 to 2. So it is only from here to someplace here. Okay, and this is the only rectangular region that I should be worried about. So and once you realize that, you say, okay, I don't need this part, right? And then the result is what you see over here in the middle as my answer in red. Okay, so you can see this this rectangular region as drawn here. You see that? It is basically 2 by 6 rectangle. Symmetric on both sides of the y coordinate, y-axis, right? And the reason this looks like a half of a piece of bread or half of a warehouse or something is because it stops when y hits 2. See, normally you would expect this to go all the way down where y is equal to 3. This would be the point where this quarter circle lands. In other words, if you draw a line from here on the YZ plane, there is an arc. There's a part of a circle that kind of goes like this. And if you continue, it'll go down all the way to here. Okay, that would be what the circle looks like. But you stop when y is 2. Okay, so the answer is going to look like this. All right, hopefully that helps. I know I provide the answer key and I say, just take a look at it. But sometimes it is difficult to imagine the thought process. And that's why I am trying to explain this in sort of, in real time so you can follow the procedure or the process of thinking. Where do I start? And, how do I, get to the answer? All right, number 3, switch the order of integration. Okay, so you switch the order of integration. First, you have to realize there's no way to do this unless you really understand what the region looks like. Okay, so make sure you understand this, and drawing or sketching is a must when you switch the order of integration, unless you're talking about a rectangular region or something. And then integrate the double integral. The integrating part is probably an easier part. All right, so let's take a look at the order of integration. It goes from x goes from 0 to 2, which means, x goes from 0 to 2. And then y goes from, both of these have the variable x in it. So go ahead and draw y is equal to x cubed, right? And you know what that looks like. This is, for some people, this is their favorite curve. It looks so cool, it just goes like, whoop, like this. And then for x, that's a straight line, right? And if you draw this a little carefully, you can immediately see this is, the origin is an intersection of both of these. And then 2, 8, right? Because you know that the slope 4 line goes through the points like 1, 4, and 2, 8. And you know that 2 to the third power is 8. Okay, so I mean, you can go ahead and solve this if you don't know what this point is. Okay, then all you have to do is to set this equal to each other. Okay, and then, I doubt that you really have to do this. X squared minus 4 is equal to 0. X plus 2x minus 2 is equal to 0. This equation, a cubic equation, of course, gives you the 3 points of intersection. Okay, now this last one, this one is -2, -8. It's not necessary because x only goes from 0 to 2, right? So you can forget this part here. All right, so the region then, once you analyze these upper and lower bounds, you see the region is, it looks like a piece of, I don't know, peach or something. Right? All right, and so now we know what the region looks like. Okay, now you have to switch the order. So you have to write this in the order dx dy, right? And so the first question you should ask is, what is y? Y goes from what to what, okay? And so, and this is for some reason, this is really difficult for some people because I think it's so much easier for us to think of this region as a vertically simple region. Why? Well, I think because we think of y as a function of x. That's how we learned about functions all these years, starting in Algebra 1, right? Well, so now it is sort of difficult to switch, but that's when your brain has to learn this flexibility, okay? Think of this as this way. So you're asking, y goes from what to what? Of course, y goes from 0 to 8 in order to cover this entire region, right? So that's why you start with this. And then you ask the question. This is the critical question here. The most crucial part of this question is to ask, okay, so for each y, pick y, x goes from this point to this point. So what does it mean? X goes from this point on the line, on the line, this line, to this point, which is on this line. All right, so what you would have to do then, and you have to realize this, oh yeah, I have to remember to write x as a function of y. X is equal to what? Right, so you rewrite this in this form, x is equal to 1/4 x, y, and then you try to solve this for x. And of course, x is equal to the cube root of y is the answer. Right? And so what x goes from this point, 1/4 y to the cube root of y. Okay, and those are the numbers you see right here. So if you are good at this, then that's great. If you are still struggling with this, try to practice with problems like this. I will have a practice test number 4 with similar kind of questions where you have to switch the order. And by the way, sometimes, okay, it's not the case here, but sometimes this integrand, you can only integrate in one order, but not the other. So the switching may be required in order to evaluate the integral. All right, so that is why you need to learn how to switch into the order of integration. All right, so now that you know what the bounds are, right? So you integrate 6xy with respect to x, so that becomes 3x squared y. You plug in these numbers for x, and of course, this one would become y to the 1/3 squared, which is y to the 2/3, and then this squared is 1/16 y squared. So you have a sort of an ugly expression here. You multiply both of these by y to the first power. So the 2/3 power now becomes the 5/3 power, and then this becomes a cube. You integrate this again with respect to y. So you have y to the 8/3, and then you have 1/16 times 1/4 times y to the 4th power. Okay. All right, so then you still have the 3 outside, but what is this when this is 8? Well, you cube 8, you take the cube root of 8, which is 2, and then you take 2 to the 8th, which is this number. Okay, and by the way, I still have this 3/8 over here, right? And then what's this thing here? Well, you take 8 to the 4th power, right? Now, of course, that's a big number, right? But I know that there's 1/16 here. So I try to do these things in my head. I'm thinking I could use a calculator to find what 8 to the 4th power is. Not on your exam because I don't allow you to use a calculator. But here at this point, you can do 1/64, right, times 8, 8, 8, 8. And you say, oh yeah, 8 times 8 is 64, so you can cancel. And so the answer is just 64 here for this part. And of course, here too, I'm thinking this is 8 over 2, 2, 2, 2, 2, 2, 2, 2, right? So, but it's 2 to the 3rd times 2 to the 5th. That's what 2 to the 8th is. And so I can cancel. You know what 2 to the 5th is? That's 32. 32 times 3 is 96. And so this is a part you can simply calculate as 32, and then you can triple it, and the answer is 96. I am not really worried about the arithmetic part or the evaluation part. I really am concerned that you understand. I am very much for emphasizing the switching the part, because that is the conceptual part that requires understanding. Okay, this part is sort of I know you can do this already because you passed calculus 1. All right, number 4, sketch the solid whose volume is the following triple integral. Okay, again, Jeopardy-like question. This may be hard to draw. Let me just warn you. This one is not easy, okay? And of course, you can see the answer. It's, oh yeah, this is not, it doesn't look bad, but try to do this first on your own, and I think you'll find it much more difficult than it appears. All right, so z goes from 0 to 1. All right, that's the first thing. X goes from this to this, right? So at this point, I am going to rewrite those bounds and then square well, let's take this part and square both sides because it's the same thing, right? If you square both sides, this and this will both give you 1 minus z, which is equal to x squared, and you solve it for z, and you get this equation. That is a parabola, upside down parabola, with the x-intercepts of 1 and -1. Okay, so I do draw a picture like this every time I want to visualize something. All right, and then y goes from 0 to 1 minus z, right? So this is what I write, and then I try to imagine what this part looks like. Y plus z is equal to 1. That's this on the yz plane. All right, now comes the crucial part. Try to put this together, okay? So I start with this. I start with this thing here, which is what I have here, right? This is what I have. Nothing below the XY floor, XY plane has to be drawn. So I just focus on the top part of it, which again looks like a warehouse, or like a building that you see like on a pier in San Francisco or something. All right, and then this equation has no y in it, so you try to extend it like this way. Okay, so it does look like this until you realize that this is also a bound, and this bound actually goes this way. Right? And this is where things get hard. Okay, now you can imagine this warehouse type of building first, right? And then now you are required to, and you are asked to draw what happens when you slice it with this 45-degree plane. So I drew this plane right here. Okay, try to imagine where it will cut through. So for instance, I know it will come out of this solid warehouse at this point, right? Where else would it cut? Now remember, this is this entire plane cutting it. So every point where y is equal to 1 and z is equal to 0, that's going to cut here, right? And here's another point where, let's see if I draw this line here, this will be right here, like this. Okay, so try to imagine this point and this point, right? So this is the plane that's cutting through this warehouse, or you can think of this as a knife or blade or something. And then try to draw that over here in this picture, okay? And you notice here, it has to go through this point, this point, this point. In fact, there should be a line on the bottom, which represents that edge, right? And then what's going to happen to the intersection of this plane and this warehouse, okay? And if you think about this, I think you can see that there should be a nice curve like this, and on the other side as well, that's going to, this curve here. And then, once you have a rough sketch, you can try to draw it much nicer. And I think I did a pretty good job here. I hope you can visualize this now, right? But the key is really to try to track these points. And if you want to, you can identify each of these points by triple, the x and y and z coordinates. Like for instance, what's this point here? That's -1, 0, 0, right? And this point is 1, 0, 0. This point is 0, 0, 1, and so on. Okay, and then in order to sketch this well, because you have to have this upside down parabolic cylinder as well as the slice, which is the cross section of these two surfaces. It may help you to draw a top view. If you look at this picture, from above, this is what it looks like. Okay, and then from the side, if you're looking at this from this view here, over here in this side, so your eyes are here, and if you're looking at this from this point of view, then the side view will look exactly like this. All right, yeah, practice if you need more exercises here. Number 5, sketch the solid and evaluate. All right, so this one is not too hard, I don't think. Okay, so let's see, what is that? Theta goes from 0 to pi over 2, so I draw a picture like this, probably 0 to pi over 2, and then r goes from 1 to 4, and by this time I have this picture in mind, right? And then z goes from 0 to 2. Oh, that's easy. You just go from 0 up to 2 at every single point. Okay, and then you try to rotate this so that you have a nice three-dimensional view. Remember, this is quadrant 1, and so you have, well, okay, so this region can be drawn like this, and I try to draw it so that you have a dotted line for the lines that you aren't supposed to see unless this is translucent or something, right? And then just take every single point on this XY plane that are sort of crucial corners, and then just draw a vertical of length 2, okay? And then do the same thing. This arc should be parallel to the bottom arc. This arc should be parallel to the dotted bottom arc, and so on. Okay, and so that's how you can get that. Evaluate. I think the evaluation is easy. You have this r. The first you integrate with respect to z, so you just get 2r. And then in the next step, it becomes r squared because you integrate 2r with respect to r. Plug in 4 and 1, you get 16 minus 1, which is 15. Take it outside. This part will just give you pi over 2. So the answer is 15 over 2 times pi. Okay, so I don't want to make this into a very long video. So let's go to stop for now and go to the next part of the video. So the first part will cover 1.1 through 5. The last part goes from 6 to the end.